The assignment is on page 313, 10 through 18 even. $32, $38, $48, $52, and $67. All right. I'm going to model some problems here. Let's see. This is section 4.6. Okay. Number 1. We'll have 2 log base 5 of x equals log base 5 of 9. Okay, solving for x. One of the properties states, well, actually, before we get to the property, let's go ahead and use the property when you're multiplying. You can bring that up and make it an exponent. So we get log base 5 of x squared equals log base 5 of 9. Okay. Now let's look at a property we can use here. Log base a of m is equal to log base a of n. If we have something like that where the bases are the same, we can just state that m equals n. So we're going to use that property right here. Since the bases are the same, we're just going to say that x squared equals 9. All right, solving that, taking the square root of both sides, we get x equals 3, or x equals negative 3. Well, you cannot take the log of a negative number. So this answer here is an extraneous solution. Extraneous solution. Remember, the domain for a log function is x is greater than 0. And so if x is negative 3, it's undefined. So our answer, our solution is going to be x equals 3. Okay, next example. We have the log of x plus the log of x plus 15 equals 2. Solving this one for x, we're going to use our property of logarithms, that when we add two logarithms, we multiply their arguments together. So we're going to go from 2 logarithms down to 1. Equals 2. So we multiplied x times x plus 15. Next, we're going to go ahead and convert this to exponential. So it's base 10 raised to the second power equals, and I'm going to go ahead and multiply this. X times x, x times 15. All right, so we have a quadratic. And so to solve a quadratic, we need to set this equal to 0. So x squared. Actually, I made a mistake. X times 15 is, I'm sure you caught that, 15x. So x squared plus 15x. This is 100. Bringing it over to the other side is minus 100. We're setting that equal to 0. All right. Let's see, can we factor this? 20 times 5. So x plus 20, x minus 5, that should work. So our possible solutions are x equals negative 20 and x equals 5. Do you know which one is extraneous? Correct, this one, because it's negative. And you cannot take the log of negative 20. It does not fall in the domain. So our solution is x equals 5. I hope you're writing this down. All right, let's look at another example. Number 3. We have 4 to the x minus 2 to the x minus 12 equals 0. Okay, so this one might be a little weird. But what we want to do here is we want to make this into a quadratic format. So we want this term to be squared, this term to just be a regular term with an x, and then this one to be a constant. So to get this to be a square term, we're going to convert 4 to 2 squared. And I'm going to rewrite it so that's 2 to the x squared. Because 2 squared is 4. Okay, and raised to the x power. I just switched the x and the 2 around. Because remember, multiplication is commutative, so they can be switched around. Minus 2 to the x minus 12 equals 0. Alright, so what we have is a quadratic here. But this 2 to the x is throwing us off. So what we're going to do off to the side here is we're going to go ahead and let u, just some letter, be equal to 2 to the x. Substituting the u in, we get u squared minus u minus 12 equals 0. Go ahead and solve by factoring. U minus 4, u plus 3. Once we get a factor, we're going to go ahead and substitute the 2 to the x power back in for u. So we get 2 to the x power minus 4 equals 0. And substituting into the other factor, 2 to the x plus 3 equals 0. All we did was substitute a 2 to the x in for u, here and here. Solving, we get 2 to the x equals 4. That's pretty obvious. X equals 2. And here we get 2 to the x equals negative 3. And that is impossible, undefined. You can't think of a number. You can't raise 2 to a number and get a negative. So this one is not a solution. This is your solution. Last one. Number 4. Example number 4. Real simple one here. 2 to the x equals 5. Well, basically, to solve an exponential, we use logarithms. So you can either use log, the common logarithm, or the natural logarithm. Let's use the natural logarithm here. So let's take the natural log on both sides. Use our property, bring the x down front. And obviously, we divide by the natural log of 2 to get x by itself. So we get the natural log of 5 over the natural log of 2. Now that's an exact answer. If we put that into our calculator, we're going to get approximately 3.322. Now, one last problem here. advanced. It's an advanced problem, but it's actually pretty easy if you have a calculator. X plus e to the x equals 2. Hopefully you have a graphing calculator. If you don't, you might try Desmos, but Desmos doesn't have the intersect function, and you really need to find where these two lines, or where these two graphs intersect. To do this, we separate it into two parts. And in our calculator, we go to y equals, and in y1, we put x plus e to the x. In y2, we just put 2. And then we use the calculator function, if I can remember off the top of my head, second trace, I believe, is for calc. And then we want to do the intersect. I'm not sure what that number is. And then we want to press enter 3 times. And then you will have your x value for your answer.